Get ready to discover the secrets behind producing consistently high-quality products in the manufacturing industries. Join me in this exciting video as we dive into the concept of process variations and its impact on product quality. We will explore the definition of manufacturing process and how it relates to process variations, as well as the importance of understanding and controlling variations to achieve the best results. By the end of this video, you will gain valuable insights into the world of process variations and be equipped with the knowledge you need to produce top-notch products. Let's get to know our friend, the manufacturing process, better. Every item that you see around you, from the chair you're sitting to most food that you are eating, comes from a manufacturing process. Manufacturing process is a transformation of a raw material to the end goods for the consumer market. In the modern day, raw materials sourced from Mother Earth will go through a series of manufacturing process in different entities before it reach the customers. All manufacturing process inputs will have materials as a key process input. Man that needs to work on the manufacturing process to transform the material. The machine that helps to transform the material, the method that is used to transform, and also the measurement process that measures the products or the material, and the environment is also another process input which is important for those products that are sensitive to environmental changes, such as sensitive electronics components. The material will go through a transformation process, and then it will be converted into a process output or a finished product of that process. And this process output could in turn become a manufacturing process input for another process until it becomes an end product which can be used by the consumer. Each of the process input that we see here, the man-machine methods material measure, will have variations. For example, for man, it could be a different operators or even the same operators, but they could be operating slightly different from time to time. It's either between variations or within the man itself, there is also a variation. And in machine, there could be a variation within the machine itself. The condition of the machine could be different. The natural wear and tear could cause the machine to have some kind of variations or a different machine that is used. Next is the method, where it could have different SOP at different time. There could be a subtle changes, and the material itself will be lot to lot differences. If you find this video informative, please give it a thumbs up and consider subscribing to my channel for more valuable insights and updates in manufacturing, supplier quality hacks to achieve consistently good quality products. By subscribing, you will be the first to know when I post new content. The measurement process, there could also be differences in terms of the person that measure or the condition of the equipment, and next the environment will have changes all the time. So these are all the source of variations that will cause the process outputs itself to also have a variation in this case. There are two types of process input variation which impact the process output, the end product, in a different way. Here, we shall look at the first type of variations, which is known as common cause variations or natural variations. This type of common cause variations are actually inherent to the process, and also it is
a very small variations such as material, there will be a small acceptable variations from batch to batch. Machine, there could be a natural drift of shift from time to time, which is acceptable. And the man that operates within the variations by following the methods, there could be a subtle differences. And also the measurement process, there is also an acceptable range of variations. This type of variations will result in common cost variations for the product itself, where it is quite stable and also predictable over time. And it should be more or less within the range or the control range itself. If the process is set up properly, the key parameters of the process output will also be within specifications. The second type of variation is known as special cost variations or assignable cost variations. These happen when something unexpected change in one or two of the process inputs itself. It could be that suddenly there is an untrained operators, and the machine, it could have used a different type of unqualified machines for the product. And the methods, there could be changes in the SOP, or there are no work instruction that has been approved before it is used in the manufacturing line.
Are you an engineer looking to enhance your skills and stand out from the competition? Look no further. Enroll in my Six Sigma Yellow Belt course at Udemy, the affordable course provider. In this course, you will learn the DMAT approach to Six Sigma through a real-life case studies and how to apply it to reduce variations in process improvement. You will also gain the knowledge and skills needed to lead a Yellow Belt Six Sigma projects and confidently answer the interview questions with clear understanding of Six Sigma complex. Plus, you will receive 13 downloadable templates to use immediately in your work. Don't miss this opportunity to take your career to the next level with Six Sigma Yellow Belt.
The material is, there could be new batch of material, or the suppliers is giving materials that comes with a special cost variations, or there could be also using new vendor that is not qualified, and the measurement process, the environment which is out of control. All these variations are actually unpredictable and they are not stable over time. Therefore, you will also produce an output with special cost variations that there could be spikes or changes that is not predictable. Most of this type of variation happens to one or maybe two process input. If it happens all the time to all process inputs, this means there's something wrong and this type of process should be disqualified. Even if it happens to only maybe one process input, it could have dire consequences to the product itself. If I plot a chart over time to check the critical parameters, I can see a certain spike. And these spikes needs to be removed at once. This means that the special cost variation should be eliminated in order for the process to go back to normal, or to have just common cost variation. There have been a lot of confusion to distinguish these two types of special cost and common cost process input which cause failure. Treating common cost process variation as special cost will drain the resources, as it is not possible to eliminate common cost variations under normal circumstances. A good example will be surface particle, which have very low reject rate on a product. And as we know, particle exists everywhere, which is a common cost variations. And we have to take extreme measure if we want to eliminate particle, such as produce the part in vacuum or in outer space where there's no particle. And this is really not an economical viable solution. On the other hand, ignoring special cost variations will lead to disasters to your customers, as this type of failure will be noticeable immediately by your customers. Do leave me a comment on your experience in dealing with process variations that you could have difficulties in differentiate. There are times like this, and I could also share some insights based on my experience if you leave me a comment.
I hope you found today's video helpful in gaining a better understanding of manufacturing, supplier, and quality engineering. I love to hear your thoughts on what topics you like me to cover. So feel free to share your comments below. If you find this video valuable, please share it with others who might benefit from it too. Thank you for watching, and I can't wait to bring you a more insightful content in my future videos.